Welcome. In this session, we are going to continue with examples of graphing using calculus. This time, we are going to do an example of a function with a discontinuous derivative. This happens for elementary functions when you have a fractional exponent, and we have done calculation with such a function, x to the 4/3 minus 8x to the 1/3. In slide 51, we found the critical values. They are at 0 and 2. We also did the sign charts for the first and second derivative, and we found the points of inflection, which are 0, 0, and negative 4, 12 times 4 to the 1/3. Let's plot those points. I'll have to find the y-coordinates of the critical point, which means I have to plug in the critical values for x and find the y-coordinate. When x is 0, y is 0, so that gives me the point 0, 0. When x is 2, y will be an irrational number. It's roughly negative 7.6. So we'll plot 2, negative 7.6. We already found the points of inflection. One is 0, 0, which I've already plotted. So there is one more, negative 4, 12 times cube root of 4. That's negative 4, and the y-coordinate is roughly 19. So we'll plot negative 4, 19. We'll also plot the x-intercepts this time. It's not too hard to calculate because we can factor y. We can factor out x to the 1/3. So y is x to the 1/3 times x minus 8. That's 0 when x is 0, or when x is 8. So the x-intercepts are 0, 0, and 8, 0. We already plotted 0, 0, so I just need to plot 8, 0. Now we have to connect these by appropriately shaped segments. So let's go back and look at the sign charts of y prime. Y prime is negative from negative infinity to 2, positive from 2 to infinity. Y double prime is positive, negative infinity to negative 4, and 0 to infinity, and negative in between, that is to say negative 4 to 0. So we need to combine the two sign charts. The other way to do that is to look at the intervals into which the critical values and the x-coordinates of points of inflection divide the x-axis into. Critical values are at 0 and 2, and the x-coordinates of points of inflection at negative 4 and 0. So if you cut the real line at these numbers, the intervals we get are negative infinity to negative 4, negative 4 to 0, 0 to 2, 2 to infinity. For y prime, we know it's negative from negative infinity to 2 and positive from 2 to infinity. And y double prime is positive from negative infinity to negative 4, 0 from negative 4 to 0, and again positive from 0 all the way to infinity. Now let's make use of this. In the first interval, negative infinity to negative 4, y prime is negative, y double prime is positive. So the function is decreasing and concave up. From negative 4 to 0, y prime and y double prime are both negative. So the function is decreasive and concave down. From 0 to 2, the function is again decreasing and concave up. In the last segment, 2 to infinity, function is now increasing because y prime is positive, and concave up because y double prime is also positive. One advantage of doing the sign charts by doing values rather than just looking at the signs is that if I had done the values, I would have noticed that y double prime is quite small in these intervals, and that would have told me that the graph doesn't curve very much, so it actually looks pretty straight. But again, in most examples we won't worry about this. This concludes this example.